A subtle but advanced question that many students often ask after they complete sampling distributions of proportions is they ask about its relationship to the binomial probability distribution. And that is the right question to be asking because when we look at probability distributions for proportions and we use the normal curve, what we're doing is we're using the normal curve as a way to approximate the binomial probability distribution that was used earlier. And the question is, when can we use? What conditions exist that we could use the normal distribution for sampling proportions in place of the binomial probability distribution? And remember, um, the formula for the binomial is very complex, and so that's why using the normal makes it more sometimes efficient to use that because the values are very close to each other, especially if the conditions are met. And those conditions, again, are based off the sample size, n times p and n times q, or n times 1 minus p. And so when those conditions are met, we could use the normal model to represent the binomial. So if you're asking that question, it's because they are related, and using the normal distribution for sampling distribution for proportions is allowed once those conditions are met. And then again, you can use this app. We have some different scenarios here. This rare event one is the situation where this, the conditions aren't met, and then you can see when we compare the probabilities. One is on the left if you do the binomial calculation for this situation, right? When a clinic gives a vaccine to 30 patients, a rare reaction occurs about 5% of people, right? What's the chance that at least four of these patients react? Well, we could use the binomial calculator to do that, or we can use the normal distribution. But in this case, the normal is not a good approximation. Notice the normal situation, it gets a 4% answer. The binomial, which is the exact answer, which gives you 6%. So keep that in mind with these different scenarios. Think about it. You can explore a little bit here. You could see different scenarios. What happens when you change sample size? What happens to the probabilities within the scenario? Or again, a better explanation of why we have both. Why do we need both? Right? What's the reason? And again, it's a little more mathematical, but it's something to keep in mind as if you notice that we use the binomial if those conditions aren't met or the numbers are smaller. Once the numbers get bigger for sample sizes, the calculations can get unwieldy, meaning really hard to do with the basic calculator. So that's where the normal distribution comes to play. But with technology, maybe it's just easier sometimes just to use binomial depending on the technology. So keep that in mind.